All right, and this is our last video for chapter 8, and it involves reactions of carbon, hydrogen, and oxygen compounds. And so this is basically burning stuff, all right? Complete oxidation or burning reactions. So what we find in these reactions is we have compounds that contain a certain number of carbon atoms, hydrogen atoms, and oxygen atoms, okay? So we have these compounds of, like I said, carbon and hydrogen, or carbon, hydrogen, and oxygen. And they're always, all right, the reactants are always these compounds plus oxygen, okay? So you're going to be given a compound containing carbon, hydrogen, and maybe oxygen, okay? And you're going to add that with oxygen. And then the products, and this is kind of easy for us to remember, are always CO2 and water. So here's an example here of a reaction. This isn't balanced, but here's the reaction shown here, or maybe it is balanced. No, it's not, okay. Where we have this carbon, hydrogen, and oxygen compound plus oxygen, that's our reactants, gives us always CO2 and water, okay? So the product side of things is pretty easy. And the reactant side of things, you're pretty much given everything. You just have to remember to write it down and then to balance the equation. So let's just do some examples together. Write the equation for the complete combustion of C2H6O2. Okay, so complete combustion reaction. So what we're going to do is write down the formula of the compound we're given, C2H6O2, and remember it's always with oxygen. So add oxygen to the reactant side of the equation. And then our products are always CO2 and water. Okay, so let's balance this chemical equation. And this one's a little tricky to balance, actually. So let's go for it. So over here, so I'm going to put the 1 there if we follow the rules from our other video on balancing chemical equations. So carbons on this side of the equation, I have 2. Carbon on this side of the equation, I have 1. So I'm going to put a coefficient 2 there. Okay. And let's do hydrogen next. So hydrogen on this side of the equation, I have 6. Hydrogen on this side of the equation, I have 2. So I need to put a 3 there. Okay. And then oxygen on this side of the equation, I have 4, I believe it is. And on this side of the equation, I have 1, 2, 3, 4, 7 oxygens. Okay, so how are we going to balance this equation now? So you may have already guessed, I'm just going to move this guy over a little bit. You may have guessed that we're going to use fractions. So here's what I like to do, okay, in these situations. And I don't know if I mentioned this in a previous video. You can look at this compound. So it has oxygen, and the fraction, though, is going to go in front of the elemental oxygen. It's something we saw in the previous video. So what I'm going to do, I don't want to put a fraction in front of this number. He's kind of, or in front of this compound, he's kind of set. That's the best way I could say it. So let's imagine, okay, I subtracted those oxygens from each side, okay? Because I want to know the coefficient that I'm putting in front of this elemental oxygen. So these 2 oxygens aren't going to play a role in the fraction part of things, is what I'm trying to say. So let's imagine, okay, I only have 2 oxygens on this side and 5 oxygens on this side, okay? Again, because I can't, or I don't want to put the fraction in front of the compound, I want to put it in front of the elemental oxygen. So I am getting rid of those oxygens on either side of the equation, okay? So now, all right, remember for fractions, now that I have the 2 there and the 5 here, the fraction that I'm going to use is 5 halves, all right? And the 2's are going to cancel out here, if you think about it that way. This 2 is going to cancel out with that 2. if we think about it that way. I'm not really going to get rid of that too, but I just want to write that so that we could think about it. Okay, so this is 5/2. And now, remember with fractions, I'm going to multiply the whole equation by 2. Okay, so when I do that, I'm just going to erase all of these guys down here. And we're going to recount in a second. All right, so that's why I felt like I could erase that. We're going to get 2C2H6O2 plus 5O2 gives me 4CO2 plus 6H2O. Okay. So now let's go through and see if we're balanced, okay? And hopefully the steps I've made so far have made sense. It's just a little bit different. There's probably another way you could do it, but I think the way I just did it is probably the fastest way for you, but there's probably other ways you could do it and come up with a balanced chemical equation. So I guess find a way that feels comfortable to you, but that way is generally pretty fast. Okay, so over here, I have 4 carbons. Over here, I have 4 carbons. Okay. Over here, I have 12 hydrogens. Okay, 2 times 6. Over here, I have 12 hydrogens, 6 times 2. Over here, I have 4 oxygens plus 10 oxygens, so I have 14. Over here, I have 6 oxygens plus 8 oxygens, which is also 14. So this is balanced. Okay. So again, you can go back and review what I just did there, and there's plenty more examples like this, I believe, in your homework and in the lab report. So you could do more of these combustion reaction balancing. Okay, let's do one. Let's see here. There we go. Okay, so I had a duplicate slide in there. So write the equation for the complete combustion reaction of C3H8. Okay, so let's say, again, we have C3H8 plus O2. Remember, it's always adding oxygen. Our products are always CO2 plus H2O. Okay, and now we just have to do the hard work of balancing the chemical equation. Okay, so carbon. I have 3 carbon on this side of the equation. I have 1 on this side, so I need to multiply by 3. Okay. And then hydrogen, I have 8 on this side of the equation. I have 2 over here, so I need to multiply by 4. Okay. And then oxygen, I have 2 on this side of the equation. And over here, I have 6 plus 4. I have 10. So I need a 5 on that side of the equation. Okay. And that's a balanced chemical reaction. All right, so that's pretty much it for combustion reactions. Here's a summary of them. You have reactants that are either carbon-hydrogen or carbon-hydrogen and oxygen compounds. You add oxygen on the reactant side. Okay, it's a combustion or an oxidation reaction or a burning reaction, all kind of the same idea. So this is what your equation is going to look like. Basically, the compound you're given to start out with plus oxygen gives you CO2 and water always, because CO2 and water are the products of such a reaction. So that's it for chapter 8. Again, make sure to do the lab. That kind of has a ton of these things for you to write and identify and balance, as well as the homework, which will give you a lot more example problems than the few I've gone over here. And if you have any questions, reach out to me. Happy to help. And I will see you, I believe, in chapter 9.